we've got a panel discussion, guys talking about controls for your hydronic systems. We've assembled these guys to share their perspectives on how to best integrate the latest technologies into your modern hydronics designs, including systems like air-to-water heat pumps, for example. We'll touch on that. Before we begin, I would like to encourage the audience, all of you, to feel free to ask questions during the session. If you have a question, just put up your hand. I'll find you. I've got someone here that has a microphone, and we can make sure everyone hears. Okay, so I'm going to ask all of our panelists to introduce themselves instead of me reading their bios. Just tell us a little something about who you are, where you're from, and a little bit about your hydronic system controls experience. I'm going to start with Mike right here.
Awesome. Thank you, Doug. Okay, so my name is Mike Miller. I'm the Vice President of Sales for TACO in Canada, TACO Comfort Solutions. Our booth is right to your left of our panel here. Been in the industry for 32 years. Started my career in Germany, where I learned the trade of heating, ventilation, and air conditioning. There, immigrated to Canada in '96. Had a couple more years experience as a contractor. Spent then a couple of years in the plumbing and heating wholesale business for a small independent wholesaler in Red Deer, Alberta at the time, who's now since joined a larger group. And then I entered the manufacturing world. And in my career, I spent 9 years working alongside Jay for some of it. For 9 years, spent 5 years at Uponor on their controls and hydronic system side, and then joined TACO about 10 years ago. Been working with controls virtually all my life. Hydronic systems is my passion, one thing I believe in, and really excites me and makes it fun to go to work every day. That's it for my introduction.
All right. Thanks, Mike. My name is Jay Vath. I'm a systems and applications engineer at Tekmar Control Systems. Been there 22 years, worked together with Mike back in the early 2000s, and made all kinds of different products. And our booth is at the back of the room here. And yeah, hydronics is like an exciting, interesting market, and we've certainly, it's been very interesting seeing it develop and grow technology-wise over the last 20 years. So I'll pass the mic over.
Hello, I'm Curtis Bennett with HPAC Controls. I have been in the industry, I guess, just as long as Jay. So for 22 years, almost 23 years. Just recently found out that I'm the oldest panelist here, which is, but yeah, controls is my thing. I'm the guy at HPAC that designs the controls, software, hardware, that sort of things. We take your suggestions to find out what we're going to build next. But yeah, same as these guys, controls is who I am, basically. So, and I'll give it back to Mike because I think he's first up.
He is. And this is, we're going to get on to our first question. I've got 5. Hopefully we'll be able to get to all 5. If not, we'll see. Our time is not on our side. Here we go. All right, so we've established that you all know your controls. So let's get to question 1. Based on your experience when it comes to hydronic system design, at what stage in the design process should the control strategy be mapped out? That's what we want to know. And why? Why does that make sense?
That's a very good question, Doug. Thank you. And I'm sure we have lots of input from this group here. It's certainly never the last thing you should think about. I always recommend start out with your system, your desired outcome, what you want your system to be at the end when it's all finished, which means what are all the components? Are you going to do heating, cooling, ventilation, any of the above? How do you want to do the cooling? What are the types of heat emitters, so on and so forth? Come up with the desired end result to the customer. That's the very first step. And then from there, start considering the controls before you get into the layout of the physical mechanical system. Because one thing I've learned over the years is it's always difficult to map a control system to a system that was already mechanically designed and developed. And I found it so much easier and advantageous to design a mechanical system that worked well with controls that were designed for a specific application. You'll hear Siggy talk about keeping systems simple, easily repeatable, easily to troubleshoot and maintain. And that's what should be the ultimate goal when designing your hydronic system. There are so many great control systems out there that have been developed and designed for specific purposes and applications that I would always recommend to build your mechanical system around it so you can use readily available packaged control solutions that are on a shelf at your favorite distributors that makes the serviceability and in the highly unlikely event of a component failure, make the replacement easy and straightforward. In my career, I can tell you we've been faced with plenty of applications that the control systems were added after the fact. Unfortunately, sometimes standard manufactured products wouldn't work in those specific piping solutions ideally. So I've been involved in systems where control systems had to be modified with custom programming and custom code, which made things a lot more challenging down the road when it comes to servicing ability and troubleshooting as well. So that's my recommendation. Make that part of your second step after you developed or thought about what the desired outcome for your customer should be in terms of heating and cooling system. Jay, anything else to add?
That's a great recommendation, Mike. Thank you. You know, it's really about you as the contractor having a discussion with your customer. Customers have specific needs that they have in their mind as to what they would like to see. So as soon as you've got your heat loss calculation completed, you're choosing some components, how many zones I have in my home or in a building, break that all down, and then you know, certainly you want to choose your control strategy, whether it's something that's built into the equipment or an external controller or thermostats. Creating a breakdown and listing all of those controls, it also helps to create a schematic as to what your system's how it's going to operate. And lastly, you don't want to start piping anything before you actually have the control strategy completed. It's a lot cheaper to make mistakes on the paper rather than getting out your saw and cutting pipe. And I'll turn it over to Curtis.
Well, I think they answered most of that. Yeah, so just to reiterate, for sure the answer is yes. Always look at the controls first. Two things that I will add. A lot of the times when people come to us with a controls question after the fact, it is actually a good idea that they've had in the system. So some of the things that we've had happen when someone comes after the fact, we've added into our controls for future people. So that's kind of the flip side of, yeah, you should, but hey, thank you for having that weird idea that time. We've got 14 other people that are going to come up and do that. So we've added a lot of applications into our controls for that. But for sure, it's like Jay said, it's way less expensive to make a mistake on paper than it is anywhere else, and that's where it all should be done first. So,
Okay, we're going to get to question 2, and I'm going to be asking Jay this one. As more system components become digital and have their own kind of communications and connectivity to them, the question is setting up an overall system control for a modern hydronic system easier or more challenging than ever before, and how do we keep it simple? So Jay, I'm going to let you start with this one.
Yeah, so for almost everything here, you will find some level of electronics on the appliance or equipment, whether it's a boiler. The heat pumps have extremely elaborate control systems and inverters. Circulators now have variable speed controllers and apps where you can change your pump curve. Wi-Fi thermostats. I mean, like that is a huge, smart and connected products are really where the market's at. So when you're taking all of these different electronic devices, it's difficult to puzzle it all together and provide that troubleshooting, commissioning, and servicing after the fact. For a lot of service companies, for example, you show up to the job, you don't know what to expect, and it can be very difficult. You might have to find the instruction manual online. You don't know if you have the right version of the manual. It can be very challenging. So definitely the level of complexity is going up. The answer to this is training. So training. It's so important to be here getting educated on new products, learning how products work from the vendors, and getting trained up and being current in your knowledge here. I'll turn it over to Curtis.
Yep.
Yeah, I for sure agree with that. As systems get more integrated with the air side and the water side now, it becomes even infinitely more complicated. You got normally closed dampers, you got normally open dampers, you got what you're running for fan speeds. They want to be integrated with modulating on that, and it just gets more and more gets built onto every system, and the controls contractor just kind of says, hey, how can I do this? So as the controls guys, it's for sure getting more and more complicated every day. The more you add two more things to it, it becomes that much more complicated. And I think the biggest thing now is the air side being mixed in with all the water side, especially with the air-to-water heat pumps, and everybody's bringing in everything into the system. It just becomes crazy. So the answer is, again, yes.
Again, there's no simple answer.
There's definitely not a simple answer. That everything is getting more complex. And we as controls manufacturers try to simplify that for the contractors and the people that are using it, but it does become complicated because one of the best aspects of controls is how many features they have. But it's also the worst aspect of controls is because if you put too many in, it makes it too complex for the contractors, but they want all of those features in there, but if they're too deep in there to get to it, so there's a really big mix that you got to get to, and it's tough to get to that point for everybody. So
I would just add that Jay alluded to the fact that training, to become a controls expert, there's a lot of needed education that needs to happen, not only on a particular control system, but perhaps also some of the control systems that are employed in some of the equipment. And about that, I would want to add that there's a lot of equipment that's out there that has control systems within it for a particular purpose, and that is to make that equipment run most efficient and most effectively. And there comes a point where you want to understand what each of one of those components do within the control systems within that piece of equipment, and then decide when it makes sense to perhaps integrate those into your control strategy, or let them run their own part of a particular system so it maintains the integrity and the efficiency of that equipment to its fullest. And then when to perhaps look at a larger complete system design and decide when it makes sense to take over the control of even that equipment in one platform. I would always err on the side of trying to keep things simple. Don't integrate things for the sake of integrating things when there is no need or place for it, but do so when it makes sense and in the whole system efficiency sort of standpoint. One thing I want to point out to that there's a lot of equipment available on the market today that's energy or Energy Star rated or whatever it may be. There's a rating for the equipment that's out there, which is usually always limited to that particular equipment in a particular setup. But if the equipment gets misapplied in an application, you forfeit some of that benefits you were supposed to get from that equipment. Where the total overall system efficiency, I feel the best bang for the buck is when we know when things need to work together and how, and control everything from a system standpoint. So again, I hope I didn't confuse the topic there, but I want to make sure that we don't overcomplicate things by trying to integrate something that doesn't need to be integrated and limit it to those applications where it makes sense. And that requires somebody that has a real good understanding of not only control systems as a whole, on what that logic can entail to make the systems function, but what's more important is a solid understanding of how the system should work together as one, especially as we marry hydronic and HPAC systems together.
Yeah. So control systems are getting complicated.
Not necessarily.
Not necessarily.
I wouldn't say necessarily, not necessarily. I would
Okay.
say there is an art to understanding when to marry equipment together or bring it under one umbrella in an effort to keep it simple for the best result.
Okay. I hope that's clear. Thank you, Mike. Okay, we're going to get on to question number 3. Here we go. It has to do, John talked about this morning, and it's outdoor reset. I thought this was an important question because I hear about it all the time. And if I do a little personal aside, I noticed the boiler in my house the other day. I went down, and there was a little cardboard box on top, and I picked it up and I looked at it, and it said outdoor sensor. So I thought, gee, why is that in its box sitting on top of my boiler? So my question is, outdoor reset seems like a no-brainer for grading greater energy and energy efficiency and thermal comfort. And in your experience, are you seeing outdoor reset being used and used correctly in applications? Curtis?
That's a bit of a loaded question. The answer
Okay.
is yes and no.
Okay.
So everybody knows outdoor reset here. This is not the 101 class. Outdoor reset has been around for a long time. It's an aspect of controls that basically, as your temperature outside goes up, your temperature in the floor or the water temperature you're feeding something goes down. So you're using less energy to heat at that BTU output or input to the house. So like Doug said, a lot of times the reset won't be set up. It won't be set up properly. So you need to know your design day for your location, which in Calgary is a -10. Somewhere in lower New York might be a -4. That's the maximum temperature that you're going to hit at that coldest day of the year. And like John had said just previously, we're only at that point for 2% of the time. So if you set up your controls wrong, or if you're just set up so you're hitting the maximum temperature the whole time, your efficiency, you're going to lose all that efficiency for that 98% of that other time. So it's a big deal to not only put the outdoor sensor in, unless the controls come with a outdoor from the web, which they do, then make sure that that outdoor sensor's on, not only for, you get warm weather shutdown with that as well, which is part of an outdoor reset, which will turn the controls off at that point, but you gain those efficiencies. And with those air-to-water heat pumps, with those COPs, it's a big deal. The air temperature outside is a big deal. So make sure those outdoor sensors are hooked up and that you've actually put the right numbers in to get that curve properly or slope properly. So I'll give it to Jay.
All right. Thank you, Curtis. Yeah, so fun fact is at the tekmar facility, we still have some outdoor reset controllers from the 1980s. All right, so this is not a new technology. It's 40 to 50 years old. Has several research papers proving that it provides energy efficiency on boilers. Can be used on steam heating systems as well, by the way, but as a timing device, not as a temperature regulator. And now with the introduction of heat pumps, well, heat pumps' coefficient of performance significantly declines when the temperature difference between your source, which is your outdoor air, or even your ground source temperature, and the operating temperature of your fluid in the heating system. So outdoor reset provides additional efficiency for your heat pump system, and it's critical to have. Like Curtis alluded to, you should have an outdoor air sensor. There's a number of systems now that use internet weather service to get the outdoor temperature. However, I will always recommend a local sensor. It will always provide the best temperature reading for your particular building. Yeah, so, and yes, we do hear of outdoor sensors, you know, installed on the top of the boiler in the box all the time. And a lot of it has to do with the difficulty in pulling wire from the mechanical room outside. So there are solutions available. Multiple vendors offer solutions for a wireless outdoor temperature sensor. So if you've ever encountered that as a challenge, certainly there are solutions available to make that easier to install. I'll turn it over to Mike.
Not an awful lot to add, I know, for the innocent time. But I do want to just add just a couple of quick things. We know it increases the overall system efficiency, and with heat pump applications, it's required to make the right decision as to when bring the auxiliary or supplementary heat. But the other point that we need to point out, or that I'm sure is probably obvious to most, but I want to say it anyway, by using an outdoor sensor, we're not only increasing the system efficiency, but also the comfort level in the home, because it allows us to deliver much more accurate heat to what the load of the building is to begin with, and therefore eliminate temperature overswing and underswing by providing too much heat when not needed or too much cool when not needed. So that's most important. But a couple other things, just because I've seen it too many times over my career. Obviously, the mechanical room is the wrong place for the outdoor sensor, but I want to point out where it should be. It should always be located on the north side of the building, because that's where we traditionally would see the most amount of shade, least amount of sun interference. It always needs to be out of the sun. Also, we want to make sure that the outdoor sensor is clear of any other potential influence that could potentially give it a wrong reading, like dryer vents, not a good place. Keep it clear of that. Otherwise, every time we do laundry at home, the system goes into a warm weather shutdown. Maybe not ideal in the dead of winter, so I just wanted to add that little bit of tidbit. Then furthermore, outdoor reset is the beginning of it, not the end-all be-all. For sure, you should have at least that, but there is another methodology that I think that should be considered more often moving forward, and that's what I would refer to as indoor temperature feedback. Because I'm sure you can appreciate that outdoor reset, for the most part, just like any other rule of thumb, perhaps, if you say, gives you a rough indication of where we should be operating. But in most cases, it's still a little bit higher than what the system might need. If you got a lot of areas in your home that have additional heat gain or heat losses from other sources, perhaps large windows or what have you, indoor feedback will add another layer of system and comfort efficiency increases by fine-tuning the outdoor reset water temperature already in place based on what's happening inside the building. Sorry.
I was only going to add one little quick thing. It's hard to get the mic from the sales guy. Only on the outdoor sensors, sometimes there's a conduit that goes through from the inside. Plug that hole, because the heat will migrate from the inside of the building into the outdoor into the outdoor sensor, and you get a false reading. So just a quick tidbit.
Okay. Very good. Isn't a thermostat an indoor?
A thermostat
Okay.
as an indoor sensor? Well, sort of.
Okay. Sorry. You had something, Jay?
Yeah, so just to follow up on that installation of the outdoor air sensor, totally agreed. Keep the hole that penetrates through the building envelope, plug that. Keep it away from heat sources like doors and windows. Also, the boiler venting is also critical. And it also helps to keep it out of the weather. So we had a good example of an outdoor sensor that would always fault out at the same time every day. It turned out the irrigation system would turn on. Sensor would get wet, have a short circuit, and then the tech would come out. What's going on? Why is the control always reading an error code? And eventually, they were out there one day, and the irrigation turns on, and it waters right over top of the sensor. And they're like, oh, well, that kind of explains what's going on. So look for other factors as well.
Okay. Just quickly, I was going to scan the crowd. If anyone has a control question for these guys that... Oh, okay.
It's mainly a little more towards like snow melt radiant, like radiant sensors and stuff. With your slab sensors outside, is it also gonna turn on with rain versus snow, or is it reading outdoor temperature to know, okay, it's too warm for things to freeze, or am I gonna be turning on all the time, whether it's raining or snowing, and kind of that awkward stage where it's sort of cold but not quite the same?
So slab
Or is there
sensor
a way
for
to
a
control,
snow melt system.
or is there a way to add on to that so it doesn't quite react that way?
All right, great question. So at least on the tekmar snowmelt controller, we actually measure moisture on the surface of the sensor. So it is, in fact, reading water. There's also some temperature sensors embedded in that. What looks like one sensor is actually like 4 sensors internal. And so we also look at how cold it is outside and decide whether it's raining or if it's snowing. So I'll give Curtis an opportunity to talk as well.
Short answer is yes. Same as Jay said, the HPAC controls are the same. We have a different way of sensing moisture, but that's about it. But like Jay said, we sense outdoor temperature. You see if it's below zero. If it's below zero or right around zero, you know that it's the moisture that's on the sensor is snow, not rain. There is also some forecasting stuff that you can use in some of the controls that will, bring in that aspect of, hey, the weather knows that it's snowing or raining at the time as well. So, but those are more not localized per your area. But yeah, it's a good question. So.
No, okay. Let's go on to this one here. Again, this kind of piggybacks. There's a lot of components and controls now offer wireless, not just digital control on themselves, but connectivity, like Wi-Fi connection on some of these components, and then also on the controls themselves to a degree. So, yeah, Jay, how about you talk to us about the benefits and what these possibilities are of Wi-Fi connectivity and controls?
So the answer is there's an app for that.
Yes.
So everybody likes apps on their phone. You can monitor everything, your health through your watch, sensors for like cameras for your house, etc. So HVAC is no different. Everybody, like the most common product would be internet connected thermostats. And of course, there's the convenience that you can operate it remotely. You can sit on your couch, turn the temperature up, turn the fan on. It also provides peace of mind. So when you're away from your property, you can monitor it and you know that it's okay. And that to a lot of owners is very important. And then lastly, you can see the performance of your system as well. So it'll track perhaps stuff like energy usage or temperatures that you can chart out on your app. So, and it's not only like on thermostats, there's apps for, boilers have apps, pumps have apps. So there's apps for almost every piece of gear here for HVAC.
Yeah.
I don't really have that much to add other than ever since we have apps, I've become my wife's comfort control when I'm not home. She calls me up and she tells me she's not comfortable, I fix it.
Yeah, on that note, I find it very ironic now that you have the ability to control your everything in your house that you actually do. How many times did you used to walk up to your thermostat and change the temperature all day long? Never. But now that you have an app, you're like, hey, I'm going to just change my temperature. Or it's the most important thing to have connectivity, which I do agree with. If you have a Wi-Fi system out there, it needs to be able to stay connected. People are relying on these systems for their information. So if you want to know if your boiler's not running, if you have cabins or cottages or somewhere you're not at your home all the time, you want to be able to see this information. It's a big deal for the connectivity. So, the company's making sure of that's a big deal.
A benefit for the homeowner and for the contractor?
Yeah, so for sure the contractor, how many times have you gone to a job site where you need to just adjust the outdoor reset curve? You can do that from the app now. So there's a lot of things you don't have to go those 4 hours for a job. Yeah, back in 2005, way back, we had some of our controls where you could do this from the computer. Wi-Fi was just coming in, so everything was LAN-based. But same idea, we were giving the contractors that opportunity not have to go to the job site, which is a big deal. And Mike has something to say.
A very good point, and I do want to add to that because there's a good use or purpose for this as well. I mean, looking at maintenance or service guys that go out to the job site, if you can have a look into the customer's system from afar before you even go there, you may perhaps be able to identify what the potential challenge might be at hand and how to go about resolving it. And as a service contractor, you might choose a different service tech to service this part of a challenge versus another. Like, if you feel an outdoor sensor might be reading off, you might be able to send, somebody different out to troubleshoot the wiring thereof, rather than if there was something critical going wrong with perhaps maybe a boiler or something. It might need to be a more technically savage tech perhaps to go after that. So it also provides some good aid when it comes to service and maintainability.
All right, gentlemen, did you have one?
Yeah, I was just going to say, rolling
Yep.
trucks is expensive, right? So if you can do it from either from your office or from your house, or even if you're on the road in your truck and you're parked, you can grab the app, you can look at what the fault codes are on systems, and you can make decisions whether or not you need to go right away. Maybe you can do a follow-up visit in a couple of days. So you can certainly optimize your work schedule around the level of criticality of the errors on the system.
Okay.
Sorry, I'll just add one thing.
One last thing.
One last thing. So from a manufacturer standpoint, when you call us for tech support, if something is connected, we can also see that whole system. So we can help you diagnose what might be wrong with the controls. So that's also a big deal from our aspect if you're connected. If it has Wi-Fi capability, get it connected. It helps everybody.